right, so we are going to solve today. We're going to solve radicals and we're going to solve rational exponents. Okay? Solving radicals has some rules that we have to follow. The first step is going to be isolate the radical. Meaning if something is being added or subtracted, we got to get it out of our way. Okay? We have to move it over to the other side. Step 2, once it's by itself, you can raise both sides to the correct index or root. So if you have a square root, you're going to square both sides, right? If you have a cube root, you're going to cube both sides, which is a power of 3. Good job. Once that radical is eliminated, you can then solve for your x or your missing variable. And then the last step says check solutions. This is a big deal when we have even roots, okay? Because they have their own set of rules. We can't square root or fourth root a negative number. Okay? So we need to plug our answer back in and make sure that that doesn't happen. Okay? You're like, why would that happen? I solved and that was my answer. It's going to happen mostly when you get 2 answers. Okay? So we're going to have to solve a quadratic today. It's coming back. Remember factoring, your favorite. Okay? We're going to do that today. We're going to get 2 answers. When that happens, 9 times out of 10, one of them is not going to work. Okay? Remember, we're trying to solve where a line crosses over a square root function or a cube root function. Okay? So we're trying, yesterday we did it by graphing. Today we're doing it by algebra. Where do they intersect? Okay? So if I have a horizontal line with a square root function, that can only have one solution, right? If I have a square root function, but my line has a slant to it, like on the board, that blue one, that is possible to have 2 solutions, okay? So that's what we're checking. Where are they intersecting each other, okay? And square roots are the ones that are going to have the issues. Yeah? Cool, let's do it. Start with our first one. We have the square root of 2x minus 1, and we have it equal to 3. Step 1 is to isolate my radical. We're good to go, right? It's already by itself. Nice. So let's move on to step 2. We need to raise both sides to the index. What index are we going to use? 2. So we're going to square both sides because we had a square root. Doing that's going to eliminate this radical. We have 2x minus 1, but now we're equal to 9. All right. Now we're going to get our variable by itself. We're going to add that 1 to give me 2x equals 10, and then we're going to divide by 2 to get x equals 5. I'm not going to circle it just yet. It was a square root, so I just need to verify that it is going to work out for me. Okay? Then you can quickly do it in your head. You can quickly type it in. I'm going to show you. We're going to check that 2 times 5 minus 1. That gives me 10 minus 1, the square root of 9. That's a true statement. We're good to go. Okay. If my original problem was equal to -3, I could have stopped and just said no solution, right? Because radicals can't be equal to negative numbers. So like the very, very beginning, when you get your square root by itself, if it's ever equal to a negative number, you can actually stop the problem and say no solution because that can't happen. There's nothing you can plug into that to make it a square root equal a negative. Right? So that's always it happens very rarely, but just something to keep in mind to look for. All right. We good? Ready for 2? Woohoo. All right. Here we go. This time I have 7 minus the cube root of 9c equals 4. Let's isolate my radical. What do I got to do first? Ooh, I can't cube everything first this time. There's some stuff in my way. Yeah. So we're going to move the 7, right? We're going to subtract it over. So I'm going to get negative cube root of 9c equals -3. I got to get that negative out of my way. So divide both sides by -1. We get the cube root of 9c now equals +3. Now we can finally bring the index. And what is my index this time? It's my 3. Good. So we are going to cube both sides to give me 9c equals 27. Final step, what's my c going to equal? 3. Good. Why did I go ahead and draw a box around that so quickly? It was a cube root, so I don't have to check, okay? Can you check if you want to, just to be sure? Go for it, if you really want to. 7 minus the cube root of 9 times 3. That's 7 minus the cube root of 27. 7 minus 3. There's my 4. Yay, we're happy. Okay, you can always check. Because you are allowed to cube root a negative number. And that's okay. The square roots is what you got to make sure that does not happen if you plug it back in. All right, ready for 3? Yes? Okay. Like all good things in math, sometimes there's more than one way to do a problem. Okay, so I'm going to show you 2 different ways to do this problem. Okay, if I follow the rules that I gave you, what should we do first in this problem? We should isolate the radical by dividing both sides by 2, right? So I get the cube root of x minus 1 equals 3 divided by 2. Right? Bring in our index, which this time is a 3. So we're going to cube both sides. So I get x minus 1 equals, you cube both pieces of that fraction. So you get 27 divided by 8. And then our last step is going to be to add that 1 over. Because it's a fraction, I'm going to add 8 over 8. Is that okay? Do we follow? Okay. So I'm going to get x is equal to 35 over 8. Okay. So some of you are like, oh, fractions. Why do we have to have fractions? They're going to be here. They're going to exist. I can't give you ways to avoid them. Okay? I can give you ways to delay them. At the very beginning, so this is just way 2. I know. You don't have to do it this way. I just like to give options. So what is special about if the radical is not isolated, but it's being multiplied or divided by something, you can go ahead and raise both sides by the index. Okay, so let me show you what that means. If I went ahead and cubed both sides, that means I'm cubing everything. I have to cube the 2, cube the radical, and cube the 3. So 2 cubed gives me 8. Cubing the cube root brings x minus 1 out of its radical, but it's still being multiplied, right? This is 2 times the radical. So this is now 8 times x minus 1 equals 27. So it's still going to happen. Divide by 8 to get 27 over 8, and then just like last time, add the 1. We still get the same thing. Okay. So sometimes it does work out to square or cube before you divide something over, so that way you don't have to square or cube a fraction on the other side. Okay, so 2 ways to do the same thing. You okay? Okay. Better quiet. Getting ready for these storms?
Yep.
Yeah. All right, number 4. I already have a radical by itself, don't I? I have 2 radicals in the equation, but one of them is already by itself. So I could go ahead and cube both sides. Okay? Another option is you can multiply by 2 first and then cube both sides. It does not matter what order you take those first 2 steps. Okay? Are you cool if I go ahead and cube both sides? Yes? Okay. I see a radical by itself. I'm going to go ahead and deal with it. So I'm going to raise both sides to the power of 3. So I know that my right side is now just x minus 7. My left side is a fraction, so I have to cube both pieces of my fraction. The cube root of x cubed, well, that's nice, it's just x. And then my denominator, 2 cubed, is going to be 8. So now how do I undo this fraction? Multiply both sides by 8. Yep. So I'm going to get x is equal to 8x minus 56. What you want to do? You could. I can't divide from there because my x's have to get put together. So you could do that, but I would put my x's together first. So I'm going to subtract 8x, but thank you for speaking up. So we're going to get negative 7x equals negative 56. And so now I can divide both sides by negative 7. So we get x equals positive 8. And again, you can plug it back in to check. The cube root of 8 is 2. 2 divided by 2 is 1. 8 minus 7 is 1. The cube root of 1 is 1. So you get 1 equals 1. It works. Do you want to see the other way? Are you good with that? I don't care. You tell me if you want to see option 2. If you had multiplied both sides by 2 first, then you would have the cube root of x equals 2 times the cube root of x minus 7. Then cube both sides would give me x equals 8 times x minus 7. And then we're at the same spot we were before. Then we go from there, okay? So you end up doing it the same way eventually. Just sometimes you can rearrange the first couple of steps if you're multiplying or dividing. All right, tell me what you see about number 5. What is special or different about number 5? There's a square root on both sides. And are they isolated? Yes, so what can I go ahead and do? Let's go ahead and square both sides. Oh, we'll do this color. Let's go ahead and do it. So when I square both sides, that means the radical goes away on both sides. I get x minus 10 equals 2x. Subtract x over. We get negative 10 equals x. That's nice, but I'm not going to draw a box because what do I have to do? We have to check. So I have the square root of negative 10 minus 10. Does that equal the square root of 2 times negative 10? This gives me the square root of negative 20. This side gives me the square root of negative 20. That is a true statement, right? Is the square root of 20 the square root of 20? Yes, that's what matters. It's a true statement. This works. Okay? That's not a problem. That's like you looking in the mirror. Yep, that's me. Okay? That's what this is showing. If I had the square root of 20 equal to positive, that would be the problem. Okay? Or if I had the square root equal to negative numbers, so like if there was a mismatch going on, that would be a problem. Okay? But they're both the exact same thing, so that is true. They will cross over each other. Okay. The next one must be the most fun because it has the most room, right? Woohoo! I told you we were going to factor today, right? Here it comes. Get ready. And you can kind of pick these out because see how I have an x in the radical and an x not in the radical? That's kind of your warning sign. It's about to get fun. Okay, you got 2 x's that we're going to have to play with. So I have 3x minus 5 times the square root of x equals 2. So I do want to move the 3x to the other side because they are not the same x, right? They're not like terms. And I want to get my radical by itself anyway. So let's subtract 3x over here. That leaves me with negative 5 square root x is equal to 2 minus 3x. Now, work smarter, not harder. Do you want to divide and then square? Think about it. 2 minus 3x divided by negative 5. Would you want to square that fraction? I don't want to square that fraction. Okay, so let's go ahead and square right now. Okay, let's square right now and then we can worry about it. So we're going to square both sides. Remember what squaring means, by the way. When we are squaring, we're multiplying things to itself. So that's why over here, negative 5 squared is negative 5 times negative 5. That's 25. Square root of x squared is the square root of x times the square root of x. That's why it's just x. Okay? Why do I point this out? Because look at what the other side is. 2 minus 3x, 2 minus 3x. Those are two binomials. So what's our favorite four-lettered F word? Foil! Foil! We have to foil. Okay? This is when it becomes special. There's foiling going on. This is how we get our quadratic that we're going to have to solve. Okay? So first, outer, inner, last. 2 times 2 gives me 4. 2 times negative 3 is negative 6x. Negative 3x times 2 is negative 6x. Negative 3x times negative 3x gives me a positive 9, and then x squared. Okay. Let's rearrange and make that side pretty. Let's put 9x squared first. Let's combine these guys in the middle to get negative 12x and put our positive 4 on the end. Okay. So we have a quadratic. Right? Yes, I'll give you that. Some of you are still writing it down. When it comes to solving quadratics, we have options. There's basic factoring. There's slip and slide. There's complete the square. There's always quadratic formula, right? Lots of things to choose from. Okay? I can't figure out which one I'm going to do, though, until I do what first? We got to make it equal to 0 first. Okay? And then we can make our choice from there. So subtract 25x from the middle. That's going to give me negative 37x. Okay. Now we can decide what method of factoring do you want to do. I can't do basic. I can't do complete the square. I could. It'd be ugly. Let's do slip and slide. Okay. Quadratic formula is always a thing. Those numbers aren't the most pretty. Okay, but you can do it. It's going to work. We'll get the same results. I'm going to show slip and slide. Okay, so we remember how to do this, right? Bring our 9 to the end by slipping. This gives us x squared minus 37x plus 36. That's nicer. Can we factor this? Say yes. What multiplies to give you 36 but adds to give you 37? 36 and 1. Good. And for this one, they have to both be negative, right? So minus 36 and minus 1. So now we get to do our slide, which means we divide. So we manipulated the problem to help make it easier, but now we do have to undo what we did to make it be back to its true self. So divide both pieces by 9. This first factor is going to be x minus 4. Our second factor does not simplify. We're just going to leave it alone. So we do have two possible solutions of x equals 4. and x equals 1/9. But we know we gotta check. There's two answers. And I even already know, because we're all math smart, that one of these is not going to work because I have this whole equation equal to just a 2. So I have a radical equal to a horizontal line, which means there can only be one solution there. Okay? There is no slant to that line on the other side. There can only be one. So like up on the board, it has to be the green. Okay? So let's test. You have a partner. One of you tests 4, one of you tests 1/9. And you don't have to do it by hand, friends. You can use your calculator. When you get to an x, do parentheses 4 parentheses. Or do parentheses 1 divided by 9 parentheses. All right, friends, which one worked? The 4 did. When you plug it in, you end up doing 12 minus 10, which is 2. So yes, 4 works. 1/9 did not work. Okay, when it gets plugged back in, you get -4/3 or -1.3. That is not a 2. Okay, so 1/9 is not a solution to it. This has a special name. Okay, it's a special kind of solution. So raising each side of an equation to the same exponent may introduce solutions that are not solutions of the original equation. These solutions are called extraneous. I know, fancy. They're called extraneous solutions. Okay, so that's what 1/9 ended up being. It's an extraneous solution. Okay, it was a solution to the factoring, but it wasn't a solution to the radical equation. Okay. When you use this procedure, you should always check each apparent solution in the original equation. So again, this is a big deal. When you get more than one answer, you have to check them. All right. Your time to shine. Yep. The mean sustained wind velocity in meters per second of a hurricane is modeled by V of P equals 6.3 times the square root of 1013 minus P, where P is the air pressure in millibars at the center of the hurricane. Estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. Okay? So take your equation and do what with it? Make it equal to 54.5 and then solve for P. Okay, so you are finding the air pressure in the center of a hurricane. So 54.5 is equal to 6.3 times the square root of 1013 minus P. I want you to solve for P and round to your nearest whole number. Right? You do this one. What's wrong? Oh, okay. Well, that's all it was. It's fine. Yeah, you're good. Yep, we should round to 938. So the air pressure at the center of the hurricane is about 938 millibars. Okay. Here we go. Now we're going to solve radical equations with rational exponents. Okay? So this is when the law of exponents come into play. What's nice is no radicals, right? We don't have to check. We're good. We're just going to solve, get an answer, and move on with life. Okay? To get rid of an exponent, though, I need to raise it to its reciprocal. Because when I raise a power to a power, I can multiply them, right? If I multiply something to its reciprocal, that always equals 1. Right? So what is the reciprocal of 1/3? 3 over 1. So 1/3 times 3 over 1 equals 3 over 3, which is 1. That's why it works. So x is by itself. The 3 to the power of 3 is 27. The end. Right? Told you it wasn't too bad. What's the answer to 8? Go, go, go. Woohoo, 16. Good, because what's the reciprocal of 1/2? It is a 2. What's up? So I'm multiplying by the reciprocal to get rid of the rational exponent. So 1/2 times 2 is 1. This is an x, but 4 squared is 16. All right, number 9. I have x to the power of 2/3 equals to 4. Okay, so again, I'm going to raise both sides to the reciprocal. What is the reciprocal of 2/3? 3 over 2. Yeah, 3 halves. Okay, because that gives you 6 divided by 6, which is 1. That's why we do it. So I have an x by itself, but here I have 4 to the power of 3 over 2. Okay, you got calculators. You can type that in. But we also know that that's the same thing as me saying the square root of 4 cubed. The square root of 4 is 2. And 2 cubed is 8. All right. Just when you're confident, I'm going to throw a negative at you. Okay? I have x raised to the power of -2. What is the reciprocal of -2? It's -1/2. I didn't change the sign at all, right? I haven't done it for my first 3 problems. I'm not going to change the sign now. Again, you want it to equal 1. So you want to do a negative times a negative. -2 times -1/2 will give you a positive 1. So do not freak out because you see the negative. It's just still going to be there. -1/2, -1/2. I get x by itself. The negative does something to my 49. Remember, there's a rule. It's telling you it's in the wrong spot. So 49 should really be what? 1 over 49 to the power of 1/2. And we know the power of 1/2 is the same thing as square rooting. So what is the square root of 49? 1/7. (11) and 12 has some adding and subtracting and multiplying going on. What's the biggest difference you see, though, between 11 and number 12? One has parentheses, one does not. Okay? So let's do number 11 where I don't have parentheses. What's the first step going to be for number 11? Yeah, we're going to move that 6 over. Good. So we're going to subtract the 6 to the other side. We get 4 times x to the power of 1/4 equals 1. Then we have to, thank you, Riley, divide by 4. So I have x to the power of -1/4 equals 1/4. My x is on its own. I am going to bring in the reciprocal now. What is the reciprocal of -1/4? -4. Good. I heard it. So I have an entire fraction raised to a negative exponent. Remember, negatives are actions. So it's telling you that the whole fraction is in the wrong setup. Instead of 1 over 4, it should really be 4 over 1. So this should be positive 4 over 1 raised to the exponent of 4. So that negative is going to make the 1/4 flip over. And then 4 to the power of 4 is 256. Okay, so you told me 12 has parentheses. How does that make it different from what I just did with 11? Yeah, I can't add stuff, right? The parentheses are grouping all that together. I can't move them. Okay? So what do I have to do first? I have to do my reciprocal exponent first. So what is the reciprocal of 2/3? 3 2s, 3 halves. So that eliminates the exponent. My x plus 1 is still here. We actually did this with number 9, correct? So we know that equals 8. And then just subtract 1 over. Do we feel good about it? I'm going kind of fast. Are we okay? Okay. Most people like the back better than the front. Two more. We got this. Think you can try 13? Yeah? We have x to the power of 4/3 equals 16. So you try 13. Yes. It won't turn on? Okay. All right, check with me. So raising both sides to the power of 3/4. That means the 4th root of 16 cubed, which is equal to 8. We good? How'd you do? We got it right? Awesome. We have time for our last one. All right. The formula Ke equals 1/2 mv squared represents the kinetic energy, Ke, of an object, where m is the mass of an object and v is the velocity of an object. Which of the following gives v as a function of K, E, and m? It wants you to take the function and solve for v. Ready, set, go. And then this is a multiple choice, so it's going to be one of these guys. I want us to take this equation, Ke equals 1/2 mv squared, and we're getting v by itself. What'd you get? What'd you get? So we multiplied by 2 first to get rid of that 1/2. So 2Ke equals mv squared. Divide by m, square root both sides, and we should get option B. Good. Good job.